This presentation is about images. Images are very important to the internet. Most of the images that you are familiar with are so-called raster graphics. Photos taken with your camera or images that you can find on the internet are usually of this kind. Some common raster graphic formats are JPEG, GIF, PNG, TIFF, BMP, and so on. The way raster graphics work is that they store image information using color values for each little piece of the image. The raster graphic divides the picture into very small squares called pixels. Then it keeps a number for each pixel that tells us the color we should make that pixel. Raster graphics are also known as pixel maps or bitmaps. One problem with raster graphics is that they're made for a specific size. When we want to change the size of our picture, this can become a problem. If our picture has a small size and we want to make it bigger, then there might not be enough information, and when we try to make the picture larger, it becomes blurry. This can be seen in this example. When we try to make the small picture bigger, the edges become unsharp and even start to show strange colors. If we look inside a raster graphic, the content is simply not comprehensible to humans. The file is just a long series of numbers. Only the computer can understand this file and display the image properly. However, there is another way to create and store images on a computer. Instead of storing information for each dot of the image, we can give instructions on how to draw what we want. Then the computer will be able to create the image. To understand how this might work, look at this picture of a little bird. When we look at the eye, we can see that the eye is basically a circle. Inside the eye is the pupil, which is another circle, and we can add another circle to make the eye more realistic. The beak is actually a triangle, and the body and the wing are formed by nice smooth curves. This means we can use mathematical formulas to draw such a picture. If you look inside a vector graphic file, you'll see that it is much more comprehensible than the raster graphic. This is a vector graphic for the little bird. Inside, we can see many words we can recognize, even words like beak or wing and so on. The parts that describe what is being drawn are also quite easy to understand. They include words like circle or path, and the numbers are easy, or at least easier to understand. If the picture we want to draw is complicated, the best way will be to use specialized software that creates this kind of file. Some typical examples of software that can be used to create such vector graphics are Adobe Illustrator or Inkscape. Inkscape is a free program that anybody can download and use. It costs nothing. It is very convenient to use, and I can strongly recommend it. However, in this class, we will learn how to make some simple vector graphics using only a simple text editor. So we won't be using any specialized software at all. Now I'll explain about one type of vector graphic that anyone is free to use, called SVG. What is SVG? SVG stands for Scalable Vector Graphic. What's convenient about SVG is that we can add it directly to any HTML file. So HTML5, which we have learned in this class, understands SVG, and most browsers can show you such pictures right away. Another advantage of SVG is that it can be styled using CSS. So we can make our SVG look nice using the CSS method that we already learned. SVG works quite similar in a way to HTML. It is written using tags. The basic tag is called SVG, and it is a paired tag. We open it and close it, and inside we give instructions for how to draw our vector graphic. The SVG base tag will need several attributes. The first attribute is called XMLNS. This attribute determines the namespace. I will not try to explain this here. The easiest way to use this is to simply copy the line with XMLNS specification for this attribute that I gave you in the instructions. The next attributes that we need are width and height. These two determine how large our image is. Finally, a third attribute that we can use if we want to is viewbox. This can be used to make our drawing more convenient. The viewbox attribute sets the coordinate system that we use to draw the graphic. This is how it works. SVG uses a coordinate system for drawing. You may have learned how to use coordinate systems in high school or even junior high school. We imagine the world described by pairs of numbers. The numbers are arranged on two lines. One set of numbers go in the horizontal direction, and the other set of numbers goes in the vertical direction. The horizontal direction is called the x-axis, and the vertical direction is called the y-axis. We can use these numbers to describe any particular point in our drawing. For example, the rightmost tip of this star here, we can see that the tip is at about 215 on the x-axis and 152 on the y-axis. This means that we can say the tip is located at the coordinates 215, 152. If you have seen coordinate systems like this before, you may usually have seen the numbers on the y-axis increasing in the upward direction and decreasing downward, becoming negative. On the computer screen, however, it is more convenient to use positive numbers in the downward direction. Now, let's look at some of the basic elements that we can draw using SVGs. First, we have the circle. A circle can be described with a point using two numbers, cx and cy, for the center and a number r for the radius. Next, a line. We can draw a line using 2 points. For the first point, we will use x1 and y1, and for the second point, x2 and y2. Another commonly used shape is a rectangle. SVG uses the short name rect for rectangles. Rectangles can be described by giving the point in the upper left corner using x and y. Then we need to specify the height and the width. Rectangles described this way will always be straight in our coordinate system. If we want a rectangle that's slanted, we'll have to do something else. Finally, another convenient shape is the ellipse. It's similar to a circle, but we have two radiuses, r1 and r2, that we can specify independently. Simple shapes will only get us so far. SVG has another method that allows us to draw just about anything we want. This is called path. To understand paths, imagine the way your pen moves while drawing. You hold your pen, then you move it to a point. You set the pen down, and you draw a line to the next point. From there, maybe another line to another point, making a curve, and so on. We can describe this path using a simple system of letters and pairs of numbers. The path tag will have an attribute D. This D attribute will describe how we draw our path. The value of the D attribute is given as a string consisting of letters and pairs of suitable coordinates. The letters tell us what to do, and the numbers tell us where to go. For example, M 200 150 will mean move to point 200 150. Then L 2586 will mean draw a line to the point 2586. And we can continue as long as we want. Drawing shapes is fine, but we also want them to look nice. First, we want to add some color. For color, we need to distinguish two things. One is the color that we will use to fill the shape, and the other is the color that we will use to draw the line that defines the shape. The first color is called fill, and the second color is called stroke. Apart from the color, we will also want to say how thick the line around the shape should be. Should it be just a very thin line, almost invisible, or should it be a very thick line? Or maybe we don't want any line at all. We can set this using stroke width. Another thing that will help us make complicated drawings simpler is to use transforms. Transforms allow us to change the position, orientation, and size of any part of our drawing. Transforms can be specified using an attribute called transform. The value of transform can be set using any of three transform methods. These are translate, rotate, and scale. This is what they look like. Translate can be used to move an object from one place to another. For example, we can move this star from here to here. Rotate will turn our shape around a fixed point. We can specify how much we want to turn. Scale will make our shape bigger or smaller. To use scale, we specify a factor. For example, a factor of 2 will make our shape twice as big. Finally, one more important tool to simplify drawing complex things is the clip path. A clip path allows us to cut off parts that we don't want. One way to think of this is using one shape as a window to look at another part. The SVG will only draw the part that we can see through the window. This can sometimes make drawing a very complicated shape a lot easier.